In last lecture, we have been talking about the hashing of the function signature. So on the example of a set completed function, when we run it through the Kesak 256 function, you'll get this output, and that's the function we are calling when we are making transaction. In this lecture, we'll continue again with the additional information lecture, and I would like to talk about hexadecimal numbers, decimal numbers, and binary numbers, and conversions between them. Okay, so usually what you are going to see in Ethereum or in other projects maybe, usually you will see the numbers in hexadecimal format because they are easier to read for a human eye. Of course, everything in the computers on the base level is in a binary, so either 1 or 0. But for our humans, it's much easier when we are working with transaction data, but work with a byte format. Or with work with a normal text, it's easier for us. Okay, but let's explain some basics how we can do a conversions between these and to convert between hexadecimal and binaries and normal decimal systems. So let's explain an example. Okay, by the way, if you have already information about this, go ahead, skip to the next lecture. It's just a bonus for you. Okay, I will get here empty node, and we will run here first hexadecimal character. So how many hexadecimal characters we have? Okay, let me go to here corner. Okay, so hexadecimal characters we have there are 16 because there is a 16 base system. So we have all right here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we are continuing with the letters A, B, C, D, E, and F. So that's the characters in hexadecimal format. So you can represent 16 numbers there, and the total is a 16 of these numbers. This is a hexadecimal. Okay, this is a hex. All right, in a decimal. Okay, decimal. Of course, in a decimal you have from 0 to 9. So this would stay the same for these characters. In a decimal format, this would be the same for this 0 until 9, but here A in a decimal would be 10, B would be 11, C would be 12, D would be 13, E 14, and F would be 15. Okay, so you have from 0 until 15. You can represent in a decimal these characters here. And when you will take a look, on any hex format, you will not find there any other letters, just from 0 until 9 and from A to F. Okay, you can notice here there will be no any other characters. And on the base level, this hex number is converted into the binary format in the computer base level. So that's a set of instructions. Okay, so here we have a decimal, and now let's proceed with a binary. This will be more complicated. We can represent all these numbers on 4 bits. This will be binary. Or binary. Like this. Okay. So we can represent this on the 4 bytes. So for example, we have 0 will be 0, 0, 0, 0. 1 will be 0, 0, 0, 1. 2 will be 0, 0, 1, 2, 0. And we have a 3, 0, 0, 1, 1. Then we have a 4, 0, 0. This is okay. Further, I will show you the example of how you can compute this by yourself. So you have these 4 characters, right? So you have a 0, 0, 1, 0. It is a binary, so the values of these bits are 2 on the 0, 2 on the 1, 2 on the 2, 2 on the 4, 2 on the 3. So this is 2 on the 0 is value in the end 1, 2 on the 1 is 2, this is a 4, and this is 8. Okay, and I'm just multiplying here. So 0 multiplied by 1 is 0. 1 multiplied by 2 is 2. So that's the value of this is 2. Because here we have a value in a 0. 1 multiplied by the 0 is 0. 2 multiplied by 1 is 2. 4 multiplied by 0 is 0, 0, 0. So only one active bit here in this bits. So this means, and the value of this bit here is a 2. So the value of this in the decimal would be 2, right? That's what I have wrote here, 0, 0, 1, 0, 0, 1, 0. Okay, so that's how it works. Depending on how many active bits you have, every bit in the decimal it has its own value. And what they are saying here, they're representing values on the 4 bits right now. We can represent it on much more bits. As in a Quetzal, we can have 256 bits. Okay, so that's a conversion. So each bit has a value, this value here. If we would add here another 0 here, this would be 2 on the 4th, and this would be already 16, right? Okay, and if I would be adding bits, the higher values I could represent. But currently we are working on the 4 bits, so that's a value 1, 2, 4, 3, and depending on the active bits, you will multiply them together, and you will get a resulting value. So when you have a 0, 0, 1, 1, and the value of this bit here is 1, this is 2, so 1 multiplied by 1 is 1, 2 multiplied by 1 is 2, so 2 plus 1 is 3, and here are not active bits, so only these ones are active, so this value on the decimal format would be 3. That's how we can provide the actual numbers in a binary format. So in a binary format, just with the 1 and 0s, we can provide so many values. Okay, we can provide any values we want. All right, so that's this, and yeah, now I can write here 0, 0. All we are when we ended up on the 4. So 4 would be actually 4 would be different. This would be okay. This would be 1 here and 0, 0. This is value of 4. As you can see here, not active bits here. So then 5. This will be 0, 1, 0, 1. Now 6. This would be 0, 1, 1, 0. Now 7. 7 would be 0 and 1, 1, 1. Now value 8, this would be 1 and 0, 0, 0. Now value 9, this would be 1, 0, 0, 1. All right. Then we have a value 10. Okay, A, it's a value of 10 in decimal. So in the decimal, value 10 will provide as a 1, 0, 1, 0. Then 11. So 1. Then we have a 0, 1, 0, 1, 0, 1, 1. Okay, I'm completely misinterpreting these numbers. Okay, so 1, 0, 1, 1. Okay, so there's 8, this is 8, 2, and 1. Okay, that's 11. All right, then we have a 1, 1, 0, 0. Then we have a 1, 1, 0, 1. And 14, we have a 1, 1. That's a 8 plus 4 is 12, plus 2 is 14, 0. And 15, 1, 1, 1, 1. All right. Okay, we have managed. So let's try to represent some hexadecimal formats. So for example, as you have here, but much shorter, okay? So let's say we have a hexadecimal number, usually denoted by 0x. You'll see in the computing that 0x is denoting this will be the hexadecimal number. Let's say 0x, 1, B, F, 2. Okay, so we have here how many bytes? We have here 2 bytes. This is 2 bytes. Oops. 2 bytes is equal 16 bits. So we have here 16 bits in total here, okay? So 2 bytes, 1 byte, second byte, 1B is 1 byte, F2 is a second byte, in total 16 bits. Now let's convert this number. First, let's convert this into decimal format. So how can we go from a hexadecimal to decimal? Similarly as this, as you can see here. So we have these numbers here. Actually, I'll write with the bigger spaces, okay? So we have a 0x. You don't need to, this doesn't have any value. So we have a 1, B, F, 2. Again, as here in a binary system, you have only 2 values. In the hexadecimal, you have a 16 value. So this will be 16 on 0, 16 on 1, 16 on 2, 16, 3. Okay, so this value is 1. This one is, of course, 16. 16 on a base 2, this is 16 times 16, this will be 256. And 16 times 16 times 16 is 4090 and 96. Okay, so that's the values you can represent here. Okay, so actually this will be really huge number what you are seeing here, because now what you need to do is multiply 1 by 2. So this number will represent 1 multiplied by 2. Value of f, you can notice here, value of f is 15. So this will be 15 multiplied by 16. The b, 256, so this will be 256 multiplied by b is the value of 11, multiplied by 11. And then 1, so 4096, 4096 multiplied by 1. Okay, so this can stay the same. So here we know that this value is 2 here. And now we can place all of the other values in the calculator. So 15 times 16. Okay, so 15 times 16, 240. Oops, 240. Okay, so plus this. Then we have a 256 multiplied by 11. 256 multiplied by 11. 2816. Okay, 2000. I have any space here. 2816. Okay, so 2816, and this number will stay. So this will have here, and we need to add them together now. Okay, so we have a 4096. So 4096 plus 2816. 2816 plus 240. 240 plus 2 is 2. 7154. 7000 is equal to 7154. Okay, yeah, that's the number. Now we want to transform it into binary format. That will be, in this case, it will be easier. Let me go back to Carbo. Okay, so number 2 in a binary format we can represent as 0010. This will be 0010. F is 111, so F is 1111. Number B, here is a B 0 1 0 0 1 0 1 1. Okay, I'm completely saying it in reverse for some reason. Okay, so 1 0 1 1 1 0 1 1. Okay, and number one should be easy. This is just a 0 0 0 1 0 0 0 1. So that would be the number in a binary format. Okay, binary, hexadecimal, and a decimal format here. Okay, so hex, binary, and here we have a decimal. Okay, we can verify it if our assumptions are right? So let's go to hex to decimal. And let's run here this number. So 1BF2. 1BF2. Convert. 7154. 7154, correct. And hexadecimal to binary. Hexadecimal to binary 1BF2. 1BF2. Convert it to binary. And we have here, okay, let's verify it. 0010. 0010, correct. 111. 111, so 4 ones, 1111, correct. Another 4 bits. 1011, 1 0 1 1, and then just a 1 here, 1 here. And they omitted these 3 zeros because they didn't went to full bits, but they just wrote it here 0, and these other zeros are basically not needed to display the full number, okay? Because their value is just a value of them is just a 0. Okay, so yeah, we have it correct. Exactly, with just these 3 omitted bits here, we have exactly the same number as we have computed. So that's how you are converting between the numbers. And your computer on the base level, when you are getting instructions into CPU, they are in a bits. They are in a bits format. But what we are displaying on our screens for our humans is easier to read in the hex formats. These numbers are much nicer. You can see only in 4 characters I can display number 7154. I don't need to write here this long 16 of zeros, 16 of 1 and zeros. And also for our humans, it's easier to read also in a text, as you can see here for this program view and edit and share buttons. All of this is in a human reading text, and there is also some encoding from you are basically encoding the numbers into letters. You are encoding bits into actual letters you can see on your monitor. Okay, and as a standardized format in Ethereum, when you're seeing here some transactions data, your bytecode, formatted code of your smart contract is in a bytes format. Okay, and yeah, any questions? Ask them, guys. I'm sorry for misinterpreting 1 and zeros when I'm talking 1 and 0, so it's in my mind it's somehow working else. Yeah, let's continue next lecture, guys, and we will be doing some practical stuff. AI lectures are important, but we need to also do some coding, and there is a lot of coding ahead of us. Cheers.